So in the previous section, when we were talking about concentration, and I showed you 4 different methods for describing concentration using a number, basically all of the problems that we went over were the type of problem where I asked you what is the concentration when I mix A and B, when I mix table salt and water, or when I mix alcohol and water, things like that. I was asking you what is the concentration. There are other types of problems that sometimes can be a little bit more confusing to students, where I actually give you the concentration ahead of time, and I ask you other types of questions like how much material is in a certain amount of liquid if you know the concentration already. So I call these types of problems manipulating the equations that I showed you in the previous section. And here's an example of one. The question is, you have 70 grams of an 11.4% mass over mass solution of table salt. How much, in other words, what's the mass of the table salt in your solution? Now, if this is confusing to you, I have a diagram that might help to explain it. So here's the situation. We have a liquid that is table salt. And in fact, we know how much it weighs. We know that the whole mixture weighs 70 grams. And so I'm saying it's 70 grams of salt water. We also know what the concentration is. We know that it's 11.4% table salt using the mass over mass method. So the question is, if we know the concentration and we know how much the whole mixture weighs, how much salt is actually dissolved in those 70 grams? That's what this question is asking. It's saying you have 70 grams of a salt water solution. The concentration is 11.4% using the mass over mass method. How much table salt is actually present in those 70 grams? So to address this type of question, we need to go back and use the formula that came in the previous section for the mass over mass method. And you can go back and look at it, but basically the formula is this. Percent mass over mass is equal to the mass of the stuff that's dissolved, that's the numerator, divided by the mass of everything. In this case, we know the mass of everything. It's given to you in the problem. It's 70 grams. And we don't know the mass of the table salt. That's what we're being asked. However, we do know the concentration. So we know that this number over here to the left, 11.4% table salt, mass over mass method, is equal to, I don't know how many grams of table salt divided by 70 grams total times 100%. So our job in this case is to figure out what x is. So basically we need to get x all by itself. To get x all by itself, we need to multiply both sides by 70 grams to get this thing out of the denominator. And if we do that, we have 11.4% table salt mass over mass method times 70 grams total is equal to x grams of table salt times 100%. And so we need to get rid of this 100% as well to get x all by itself. To get rid of the 100%, we divide both sides by 100%. When we do that, we will get x. And x is equal to 11.4% divided by times 70 grams divided by 100%. And if you do that out, you will come out with about 7.98 grams. So if I told you that you had 70 grams of salt water and you knew the concentration of the salt in the salt water was 11.4% using this method, you could figure out how many grams of table salt were actually dissolved in those 70 grams. And it turns out to be about 7.98 grams of table salt. So that is, manipulating the equations in a way that's different than what we did in the previous section. This is a different type of problem. Actually, it's similar to the one that we just did, except it's using molarity. So I want to do a molarity type question just because these tend to be a little bit more difficult for the students. So again, we're going to know the concentration using the molarity method, and we're going to know the volume. And we're going to have to figure out how much is dissolved. So you have 0.3 liters of 2 molar sodium chloride. So we know the concentration, that's this. We know the volume of the liquid, that's this. And the question is, how many grams of table salt are dissolved in the liquid? This question requires a couple of steps. First of all, the question is asking us how many grams of table salt are dissolved in the liquid. But if you remember the formula for molarity, molarity is the number of moles divided by the number of liters. So whenever we figure out the number of moles of sodium chloride, that won't be enough. We're actually going to have to convert the number of moles back into grams. So this is just a reminder, the molar mass of table salt is about 58.4 grams per mole. And if we know the number of moles, we can figure out the number of grams. So here's a cartoon version of what's going on. We have 0.3 liters of salt water. Here's our 0.3 liters of salt water. The concentration of salt in the salt water is 2 molar using the molarity method. And the question is, how many grams of table salt are actually dissolved in those 0.3 liters? So we have to go back to the formula for molarity. And there it is. Molarity is the number of moles of solute, and in this case the solute is sodium chloride. So basically, in our case, it's the number of moles of table salt divided by the number of liters of the solution. Well, we already know the number of liters of solution, so we know the denominator is going to be 0.3. So, and we know this number as well. We know the molar concentration because that's given to us in the question itself. So we know this number over here on the left, and we know the denominator. The number that we don't know is the numerator. How many moles of table salt are actually dissolved in 0.3 liters? However, we need to get this number all by itself. So to get this number all by itself, we need to multiply both sides by the denominator, because we need to get rid of the denominator on the right side of the equation. If we multiply both sides of the equation by the denominator, then basically I've flipped this around. So number of moles of solute, the numerator here, is now on the left, and molarity times the denominator is over here on the right. So moles of solute, which was the numerator over here, is equal to the molarity, that's shown here, times the number of liters of solution, which used to be the denominator. So now we have how many moles of sodium chloride all by itself. And we know these two numbers over here. We know the molarity, it's 2 molar. We know the number of liters of solution, it's 0.3 liters. So moles of solute of table salt, in other words, moles of table salt, is equal to 2 molar times 0.3 liters. If you multiply these numbers together, you will get 0.6 moles of table salt are actually dissolved in our 0.3 liters of salt water. So, but this isn't the answer we're looking for. This is how many moles of table salt are dissolved in our 0.3 liters in our mixture. The question is how many grams of table salt. But if you remember, I said that if you know how many moles of something you have and you know the formula, which we do, we can figure out how many grams of it we have. So we know that the molar mass of table salt is 58.4 grams. So there are 58.4 grams of table salt for every 1 mole of table salt. But we don't have 1 mole of table salt. According to this over here, we only have 0.6 moles of table salt. So the question then becomes, how many grams of table salt is equal to 0.6 moles of table salt? We cross multiply and divide again to get x all by itself. X is equal to 58.4 times 0.6 divided by 1, which is just 58.4 times 0.6. If you multiply that out, it comes out to about 35 grams. So this is a long couple of steps to get to the answer, but you can get to it if you understand these concepts. The setup to the question was that we have a liquid that is 0.3 liters of salt water. We know the concentration of salt in the salt water mixture. It's 2 molar. The question is, how many grams do we have? Well, we can't figure out the number of grams directly. We can, however, figure out the number of moles of table salt directly, and we figured out that it was 0.6 moles of table salt dissolved in those 0.3 liters, and then if we knew the number of moles, we could figure out the number of grams. And that's what we did. So there happened to be 35 grams of table salt dissolved in our 0.3 liters of salt water if the concentration is 2 molar. And so that again, I realize is probably a somewhat difficult question, but there it is. If you work on understanding what molarity is and sort of working through these formulas, you can certainly get there. So that's it for molarity and concentration. So in general, concentration is how much solute is dissolved in a certain amount of solvent. If you have something with high concentration, what that basically means informally is that you have a lot of solute dissolved in a certain amount of solvent. And if you have low concentration of solute, that basically means, again, informally, that you don't have a lot of solute dissolved in a certain amount of solvent. And there are many different ways of describing concentration. And I showed you 4 of the ways in the previous section. Basically, there was percent mass over mass, which is also known as percent by mass. There was percent by volume. There was mass over volume percent, and then there's molarity. So those are the 4 major methods for describing concentration numerically.